Alright guys, so we're looking at problem 10 from the Fall 2014 Physics 2048 exam. So the problem reads, a beanbag is thrown horizontally from a dorm room, from a dorm room window. The height of the window is h equals 10 meters above the ground as shown in the figure. If the beanbag's velocity just before impact with the ground is theta equals 30 degrees below the horizontal, at what horizontal distance in meters from the dorm directly below the window from which it was thrown does the beanbag hit the ground? Ignore air resistance, or instructed to ignore air resistance. So the first part is, we gotta recognize that this is a velocity vector, which can be broken down into components that I'm gonna write in polar form, which is gonna be the magnitude, which I'm just gonna call it big V, cosine, now we're told the angle, so we know that it's cosine 30 degrees, comma, big V, sine 30 degrees. Okay, now that we have that, we are going to use a kinematic in order to solve just the vertical component. So we're going to find what this is, just what this is, and we're going to do so by visualizing the beanbag as being thrown vertically, launched vertically, and that's going to represent the y component. So it's going to, first let's write our kinematic. Bf squared equals bi squared plus 2ad. And we're told what d is. We're told d equals 10. We know the acceleration of gravity is 9.8. So, and we know that vi, the initial velocity of the beanbag, is 0. So from that information, sorry, I don't think you could see, but so here we know initial velocity 0, d equals 10, a equals 9.8. Of course, I haven't used the units, but it's meters per second squared, meters, and meters per second. Okay. Now, we're gonna start plugging that in order to solve for Vf. Vf squared is then equal to 0 plus 2a, which is 9.8, times 10. So now we are just going to find out whatever that is, and that should be equal to 9.8 times 10 is 98, and then 98 times 2 is going to be 196. That's what I thought. Okay, so 196 equals Vf squared, and then Vf then in turn is going to be the square root of that 196, which is equal to, where did I put the calculator? Okay, here it is. Let's use a handy calculator, and that's going to be 196, the square root of 196. 196, it's 14. Okay, perfect square. I love for perfect squares. Okay, 14 meters per second. Now let's look at something else. Now that we have the velocity, the vertical velocity, we can actually figure out the time it would take for the beanbag to reach the ground from all the way up. And the way we do that is, well, v, the velocity that we just found, vy technically, I guess, vy, that's the y component, equals the acceleration of gravity, which we're calling a, I'm going to call it a, it's also called g, and that's going to be a multiplied by t. And we know what vy is and what a is, and that's going to tell us what t is. So what we're going to do is just solve for t. So we know vy is 14, so 14 divided by 9.8 seconds equals t. So that's how much. And I'm going to leave it in this format just for the sake of simplicity. I don't know. You know what this is. You can calculate what this is going to be. So now for the next part, we are going to find the magnitude of the bag before it hits the ground. So in order to do that, we need to understand that the magnitude represents this big V right here. So I'm going to use the y component that I know is equal to 14, and I know 14 equals V, which is the magnitude, times sine of 30 degrees. There's another fact that I know. So all I really need to do at this point is solve for the big V, which is a magnitude. So 14 divided by sine of 30 degrees equals my big V. That's going to be my magnitude. So 14 divided by sine of 30 degrees. That's going to be 28. 28 equals big V. So now I actually know what the magnitude is. And knowing what the magnitude is actually quite helpful, because that way I can actually find the x component. The x component of my velocity vector. Because this V is the same as the one here on the V cosine theta. So it's very convenient that I have that. So I am going to simply look at this. This is going to be my x component, and it's equal to 28, which is V, times cosine of 30 degrees. And that is equal to, well, it's about 24.24, so it's about 24.87. And you know what, I am just gonna leave it. I'm gonna start using this format. You know what it's equal, you can calculate it. So at this point we're actually almost done. We know all we wanted to calculate ultimately is just the displacement of the beanbag, the horizontal displacement. So we're actually going to use just the x component because we just want to find how much it moves. So we have a velocity component, the x component, the horizontal amount of time it takes, amount of distance it takes in a given period of time. So all we really have to do in order to find distance is multiply the x component times time, which we already found right over here. So it kind of goes back to this earlier part of the problem where I had t equals 14 over 9.8 seconds. So now that I did that, I'm just literally just going to plug in my numbers. So it's Vx, which is 28 cosine of 30 degrees times 14 over 9.8, and that should give me my horizontal displacement. So 28 cosine 30 times 14 over 9.8 is about 34.64 meters. So here we go. It's a bit of a long problem, but it's multi-part, but ultimately I got the answer.